Hey everyone, my name is Jaime. I'm from Advanced Test Equipment, and today we're going to be going over some of our conducted immunity sweep testing equipment. In this video, we have the Schlauder CDG 7000 unit. It's a 3-in-1 test system that comes with a signal generator, an amplifier, and power sensors. We're also going to be showing the VectaWave VBA 4000-110. It's capable of going up to 10 kilohertz to 400 megahertz and 110 watts. In case your tests require a higher or lower frequency or more power. We also have the Schwarzbeck CDN M5PA. This unit is capable of going up to 63 amps, 1000 volts, and is 3-phase 5-wire. We also have a Prana bulk current injection probe. It's capable of going up to 500 watts. And when you do rent from us, we give you the whole test setup, so you're able to get some calibration fixtures as well. And we also have an RF current probe that's capable of going up to 10 kilohertz and 500 megahertz. So in this video, we're going to do a self-calibration to make sure that your equipment will be able to test to your standard accordingly. So let's get started.
So currently I have my CDG 7000 output going to my 6 dB attenuator, which then goes into my bulk current injection probe, which I have an RF load on one end, and I have the RF cable that goes to my power meter input going to the front of my CDG 7000. Just keep in mind every power meter input has a max drive level, so make sure you start off low and don't overdrive because you can damage your very sensitive test equipment. So now that we have it hooked up, we're going to hit go on the software and let's see what the calibration levels are going to be. So now that we have our HELIA software up and running, you can go into dummy mode and play with it offline, but I already have my CDG 7000 connected via USB, and I have that licensed USB dongle also connected to my PC, so it recognizes this is a licensed copy of the software. Quick things you can do is if you go into the settings, you could actually set a maximum output on your signal generator, so that'll help you not overdrive something or potentially overdrive the RF input connection, but you want to definitely double check all your math to make sure you don't overdrive the RF in. I think it has a 33 dBm maximum input level. So for today I'm going to leave my max output level for the drive to just minus 5 dBm. And once I'm back at the main menu, before I begin running a test, I'm going to go into test level and I'm going to create a calibration file for my CDN. So once this opens up, I can go into the name and I'm going to name my coupling device a CDN M5, since it's a 5-line CDN, 63 amps because it's 63 amps per phase, and 1000 volts since this particular CDN can do something like close to 700 volts AC and then 1000 volts DC. And then you can also change your impedances. You can change whether it's a logarithmic, linear, or single shot. Whether it's a voltage measurement or a magnetic field. Keep in mind on a magnetic field, that'd be more for the magnetic field immunity test, but we're going to do the 4-6 today and mil standard 461 CS114, so leave it at voltage. For the test level at the device under test, when you change this, it'll change the dB microvolt test level, but for today's example, we're just going to try to calibrate a 1 volt drive level, so let's stick that to 1 volt. You could adjust the frequency and the step size. I'm going to speed this up today, so I'm going to change the step size to 8% per step increase to speed it up. And then the two windows I have here are the RF in, so that's coming into my built-in power meter on the CDG 7000. And the RF generator level, so that's how much drive we're supplying to the internal amplifier, or down the road when I supply the drive to an external amplifier if you needed need more power than the built-in amp or a higher or lower frequency range. Keep in mind, if you click on this channels icon, I can select different channels to drop inside the window. So like for example, I'm going to add temperature, and now it just will show you the temperature, but there's a few other things you can see. So now I'm going to get started with the cal, so I'm going to hit the play button. And on the actual values, what you'll see is the drive going into the amplifier starts to get stronger, and the system will keep increasing the drive level until you hit 1 volt on the measurement port, and then it will start sweeping frequencies. And on the chart over here, you're going to have what is your signal generator output level, and then the chart on the left, you're going to have how much power is being measured on the built-in power meter on our CDG 7000. So we're going to let it run here for a few minutes, let it sweep the whole frequency range, and then we're going to see what it's going to show at the end. So now that our CDG 7000 finished its calibrated sweep, you're going to have this correction factor from the signal generator, so you're going to know how much power it needs to drive, and then we're going to use this when we actually run a test. So I'm going to make sure this is saved, and then we're going to go back. So now that I'm back in my main menu, what I can do is, instead of going into the settings to set the test level, I'm going to go to New Test and Sweep. And once this opens up, it gives me a whole set of other screens, so I can change around whether it's a voltage, magnetic field, what's going to be my start and stop frequencies, what's the step size, the dwell time, what's going to be my test level. For my example today, I'm going to leave it at 1 volt. And I'm not going to use a current probe, but you can also technically use a current probe to measure downstream to make sure you are getting the signal onto the device under test. You could also make sure you have the right modulations, internal AM, external AM, pulse modulation, whether it's a sine, triangle, or rectangular waveform, the frequency of the modulation, the level of the modulation, and the duty cycle. One other thing is we're going to go to the coupling devices, and I'm going to select our calibration that we just did on our CDN, and I am going to make sure that it matches everything. I think my step increase, I believe I did 8% per cycle, so now that little yellow icon went away, telling you that this is the same setup that you had under your cal. So when I'm ready to test, I'm gonna go ahead and hit the test button. So give me a second to get it all set up here. And I'm going to hit start sequence when I'm ready. And right now, since I don't have a current probe set up, the chart on the left is going to show any RF power in, but the RF generator level on the chart on the right will show you how much power is being delivered to the internal preamplifier, which matches the pre-calibrated curves that we did earlier. So we'll let this run for a few minutes. So Now that our test is finished, we can see how our device under tests, whether it malfunctioned or if there was any defects. And I can also go into these menus over here and save the recording, or save the completed sequence, or create a report. So if I hit the create a report button, I can save it and pull it up. On this screen here, so it'll give you different parameters of the test you just completed. So that pretty much sums up our demo today, and definitely keep us in mind at Advanced Test Equipment Rentals when it comes to renting, purchasing, or calibration of anything conducted in Unity. We carry the widest selection of generators, bulk current injection probes, CDNs, EM clamps, and current monitor probes. And for calibrations, we're accredited to calibrate most of this equipment too. So we'll catch you next time. Bye bye.